Chapter 1, Part 2. So where did this all start? I'm going to give you a little history, not very long history, but a little history so that we get an idea of what this is good for and kind of where it came from. So if we go way back in time, over hundreds of years, there have been all kinds of card games and dice games that people have played. In some cases, there were rich guys who wanted to win, and so they hired mathematicians to figure out how to win at these games. Sometimes it was just a regular person who had dreams of getting rich by figuring out how to win at these games. Either way, a whole bunch of math got done, and what we figured out was that a lot of the games that used to be played weren't governed by that rule of uncertainty. There was a way to guarantee you'd win. All of the games that there's a guaranteed way to win have gone away, and we don't see those games anymore. The games that we still play are the games that have that era of uncertainty, that chance that you can win and that chance that you can lose. You can't figure out necessarily who's going to win a dice game the way we play dice games or a poker game. So those games of chance created a whole bunch of math. That math was used to figure out that certain games were winnable in a guaranteed way and certain games were just going to be uncertain. That there's maybe better strategies, but we don't know who's going to win. The math from those continues to be useful and is something we're going to learn here pretty soon. The next thing that happens to us is a guy sitting around at tea time at his university. This is a guy whose name you're going to run into many times, whose initials are R.A. That stands for Ronald, and I can never remember his middle name. And his last name is Fisher. So Ronald Fisher, R.A. Fisher, is a math student. And he's at a prestigious British university where every Friday afternoon the students sit around with each other and have tea. And they don't sit around with just their friends. They're kind of assigned to mix up so that you meet different people and you get to know your classmates. Well, one day Fisher and some other folks, some other men, sit down at a table where there is one young lady. And of course, this is over 100 years ago, and young ladies were fairly rare at universities at that time. So she becomes the center of conversation, and when Fisher offers to get her some tea, she says, "Make sure you put the milk in first, because if you put in the tea first, I can taste the difference, and I like it better, the taste, when you put the milk in first." Well, none of the guys at the table really believe this, but because three college men and a college-age woman are sitting there, they decide to come up with a test for her, and they spend the afternoon with her trying different cups of tea and telling them whether she thinks the milk went in first or the tea went in first. What we know from this story is she tried a couple of dozen different cups of tea, and she was right every time. She knew exactly whether it would be milk first or tea first. Now Fisher, when he goes home that night, he's sitting there alone, and he's a math major, but he didn't really know what he wanted to pursue with his life. He starts to think about a really kind of simple question. She is 24 out of 24. That tells you she probably actually knew what she was doing. What would happen if she just guessed? Well, if she just guessed, she'd probably get 12 or somewhere close to 12 right. So how many does she have to get right before we believe that she's not just guessing? Is it 15? Is it 18? 20? 22? Fisher spends the rest of his life writing book after book after book and doing real-life research on exactly that question. How many cups of tea should we test her on? And how many does she need to get right? and can she repeat it? So he develops all of these statistical techniques, and the book and this class are wall-to-wall, end-to-end R.A. Fisher and his statistical techniques. And it's all about this random event where he runs into this woman who can differentiate the milk and the tea. What Fisher did for most of his life was deal with issues of farms. What they had done was this huge agricultural company in England. They had farms all over England, and when they developed a new fertilizer, they'd pick half of the farms, and they'd put the new fertilizer on them, and half the farms, and they'd put the old fertilizer on them. And that's how they'd decide whether the new fertilizer was better than the old fertilizer, or a new seed they came out with was better than the old seed. They'd scatter it all these farms all across England, 1 year at a time. So they had warehouses full of data, and I mean warehouses full of data in boxes on paper. This is, again, 100 years ago. They hire Fisher. They discover Fisher has done all this work while he's in college, and they hire him to go through their data. And what he discovers actually is that there's warehouses and warehouses full of data are all meaningless. The data is just garbage and needs to be thrown away. Reason? Well, the weather might be different in different parts of England. And if you put new fertilizer on the farms in the north and an old fertilizer on the farms in the south, or vice versa, or farms down the street, or farms that have different... You see the problem. There's so many factors that are going to determine whether the seeds grow. It's not just the fertilizer. It's how much water they get, how much sun they get, how good the soil is. And if you don't adjust for those, if you put those plants or that fertilizer or those seeds anywhere, you're not going to get an answer you can trust, because maybe you tested those seeds in a year where it was low moisture, where it didn't rain very much, and then next year when you put them in an environment where it rains a lot, maybe they grow differently and we don't realize it. So Fisher had to redo this whole system and figure out how to make this work. And of course, he does, and he spends his life doing it. It's not going to be just the farmers, in fact, that did this. It turns out that his techniques are improved upon, and new techniques are come up with by people in industries like breweries, people who did things that you wouldn't think are statistical at all, like how do we get beer to be of consistent quality? And yet those folks go out and invent new statistical techniques that we still use. So hopefully we have some idea of where this comes from. It comes from people looking at real world issues and trying to figure out ways to kind of beat the system. All right, so now we're just going to talk about data and some categories. Statistics itself falls into two basic branches. Remember, we said we do three things with statistics. We simplify, we analyze, and we make decisions. The simplifying part of statistics has the lovely title, descriptive statistics. So when you hear something say we're doing a descriptive analysis or we're doing some descriptive statistics, that means that they are simplifying their data. The part of statistics which is way more fun, which is analyzing and making decisions, is called inferential statistics, making an inference. All right, data. You go out and you collect a bunch of data. All of your data together are called a data set. Each individual person or business, let's say you go out to a casino and you collect data on 100 people who walk in. You just take the next 100 people that walk in the casino and you collect data on them. All of the data on those 100 people are your data set. Each person is referred to as an observation or a data point. So we have 100 observations, all those people. If I measure how long each person stayed in the casino, so one person stayed 10 minutes, one person stayed 30 minutes, one person stayed 90 minutes, and I have this list of how long each person stayed, that list of how long each person stayed is called a variable or a data series. We can draw this out, make it look like a matrix. So here we have a data set. We have 4 students and their GPA, their SAT score, their age, and their height. So maybe we're trying to do an analysis where we're trying to predict your GPA in college based upon your SAT score, your age at starting college, and your height. Not that we chose those because perhaps those are the best variables, but 3 things that we know. So the 4 people, Jen, Morgan, David, and Wally, those 4 people are the observations. GPA, SAT, age, and height are the variables. And the whole thing, all 16 numbers, are the data set. So some other things. Qualitative and quantitative we already talked about. Qualitative data means data that we can't describe in numbers. Male, female, blue, green, black, brown. Quantitative are numbers. Your GPA is 3.6. You're 20 years old. Another group of categories we put data into are time series and cross-sectional. Time series, logically enough, are data that go over a period of time. So time series data would be, we take the Mirage Hotel and we look at its gaming revenue from 1989 every year to the present. So we have a series of data. Those data span almost 30 years and 1 point per year, or it could be 1 point per day, hour, minute, second, microsecond, doesn't matter. But the data span a period of time. Cross-sectional data are data that are in an instant of time. So if we take every hotel in Las Vegas and we figure out their gaming revenues in 1989, that would be cross-sectional data. It's at an instant of time, it's 1989, and it's a whole group of hotels. If we combine those two, so we take a group of 20 hotels and we look at their gaming revenue from 1989 to the present, now we have what's called panel data, or some people call pooled data. It's a combination. Each hotel, we have a time series, but we have a group of hotels, which is a cross-section. So it's a cross-sectional and time series merged together, called a panel.